Good afternoon, everybody. I'm Mona RAKIBE, co-founder, CEO of TELMAI. And today I'm going to talk to all of you about data observability. So quick show of hand, how many of you are familiar with data observability? Wow, that's awesome. Quite a lot of you. So we're going to do it a little bit differently. We're going to look at data observability use cases a little bit beyond data quality and incident management. So a little bit about myself. As I mentioned, I'm Mona RAKIBE, co-founder, CEO of TELMAI. It's a data observability company that we started 2.5 years back. Okay, thank you. Okay, and we help companies build a reliable foundation of data for their modern data stack. What I would like to cover is, what is data observability and why now? Like, data has existed for so long, data quality issues have existed for so long. What is this big moment that we all are focusing on data observability about? We're going to talk about the use cases areas, but I'm specifically going to talk about two use cases that probably you haven't heard, is how data observability helps your AI initiatives. And I was told that if you don't use large language models or generative AI, I would be kicked out of the session. So I had to use that for my demo. And the second thing I would talk about, the use case I would talk about, is a little bit deep dive in, we are all building data products and how data observability can get you better ROIs on your data products. So what has changed, right? What has changed? Just in last 5 years, if you look at the landscape of data itself, the tools we are operating on has seen an exponential change, like the volume of the data has changed, the velocity has changed. The MAD landscape, as Matt Truck likes to call it, the ML, AI, and data landscape, is full of different tools. So as users of your data ecosystem who are working with architecting your data pipelines, moving data, ingesting, transforming them, we are working with really complex systems today. And what that has led to, data engineering through research has been saying that data quality and validation tests rank pretty high in the challenges that the teams are seeing today. And these challenges are also causing data engineering to become one of the fastest growing job in recent years. There's lots of things that are happening around data, the movement of data, the infrastructure of data, and yet we do not confidently feel that the data that's fueling your business decision is either reliable, trustworthy, or you have a good understanding of what that data is doing. So that is the problem that observability is going to solve. And if I had to, wow, if I get this working. Okay. So if we put it quite simply, the data use cases have evolved a lot from AI, ML, data products, operational analytics. Data itself has evolved a lot, like high volume, high velocity data. The tools in data reliability, however, are still rigid rule-based process which have delays, manual ways of looking at data, stewardship. This is leaving a tremendous gap in our ecosystem today. We don't have efficient ways of looking at data, no automatic detection of data quality and reliability, a lot of manual work, a lot of sampling, and hence there is at least three different areas where we are seeing people are focusing to improve data reliability: data observability, data contracts, data catalog, and I'll talk more about data observability here. So with the problem statement defined, what exactly is data observability? You might have heard every vendor has their definition, every analyst has their definition. The definition itself is evolving as the category is. But we all know we have borrowed a concept from control theory, which says that if you look at external system, if you look at the symptoms of a system, can we predict that there's something wrong going in the system? And that's the foundational principle of data observability too. Can we take all the metrics, can we take the metadata, data, distributions, all of these things, all of these metrics, and aggregate and predict if there's something wrong with the data? And that's the foundation of data observability, where we are using data science, statistical analysis, and the technology that we know today to solve the problem that we've been seeing for years now, which is data quality, data reliability. And that is where why now is we can do it today because we have the technology today. We have Spark, we have high compute, and we can do all of this metric calculation. So think of data observability almost like a wearable device. Now you have signals going through your body telling you if you have issues with, and this is the same principle on your data, your enterprise data. With that said, if you look at a signal calculation system like a data observability system like TELMAI, at the very least, you can classify the type of problems a data observability system can solve in 3 main categories. The slide is a little bit messed up. It doesn't cover the categories. I'll speak through that. The first slide here talks about your pipeline efficiencies. So as I mentioned, we, as a data observability company, what we would do is that we can look at the signals of your data. These signals could be metrics around metadata and things like that. Can we use the aggregation of these signals to find out, is your pipeline efficient? Is it cost optimized? Because it's a very big concern today. We are ingesting so much of data. We are processing it. Do we have the right SLAs and proactive measures for the pipeline efficiency itself? So think about the first use case category for data observability is efficiency around your data pipelines. So a lot of companies today are aggregating and right away giving you metrics and monitoring about your underlying pipeline system. The second one is strategic, as you can see. The second pillar here is how can we be strategic about the data and the health of the data, and how can it drive better strategic initiatives. So first thing is like data quality discovery and interactive testing. Typically when we talk about data quality, we talk about validation, governance rules, and other things. But now that we have implemented observability in a system, you can take the metrics from observability, classify them into data quality KPIs like completeness, accuracy, uniqueness, and so on. This is all automated. This is another use case of data observability. And then you can monitor your data on data quality KPIs. You can establish data quality rules real time. This is also an outcome of observability that you can leverage. Once you have data that is reliable, you will be able to build reliable data products. When we talk about data products, it could be your analytics reports, it could be your data science-driven ML models, and so on. How do you make sure that these data products are delivered in a timely fashion? You're able to deliver more data products in a reliable manner. So that's another outcome of data observability. And the third one is data quality and governance specifically. So once you look at observability metrics, you can actually monitor things like, is your data out of compliance? Let's say you have policies on your data that your data cannot live for more than 7 years or 6 years. You can use this data observability insights and throw these rules on top of these insights to monitor the data that it doesn't go out of compliance. So that's the third pillar of auditing data, having policies around data, and augmenting your data catalog with data quality KPIs. So we have data catalog. Some of us use data catalog to maintain data information, who has access to the data. How about if you start getting information about how healthy is this data? Are there open alerts? Are there open issues on top of this data? And if those insights are there, you are able to address 3 key pillars through data observability into your ecosystem. So when we classify data observability, typically all of us think of 2 things. One is data quality. Data observability is equal to data quality, or incident management, which is typically my pipeline is breaking, there's an issue in the pipeline. However, there are many other use cases, and I'm going to just touch a couple of them. First being large language models. So what we did at TELMAI is, everybody knows that, or there is enough said about, okay, if your underlying data is bad, your model performance is going to be bad. Data quality is an essential step for your large language model training. We ran some experiments here, and this experiment can be found on our website of TELMAI. There are source code, so you can try it out yourself. What we did, we took a simple example of data that is readily available. We took an existing large language model, which we had to fine-tune on the data, which is about books, and had to classify whether the based on the titles and the content of the book, if the books are fiction or non-fiction. So it was a prediction model that we had to work on. What we did is, we tried to train this model on 2 different data sets. One was where there was a lot of noise, raw data as it is. Typically, this data, especially for large language model that's coming, will be NLP extracted data, and which may have things like truncated fields, mixed up data, like unbalanced fields, and so on and so forth. So we left it as it is. And we ran this experiment on this type of data. And as expected, there was a tremendous amount of difference in the precision of model and even the cost of training when you leave the bad data as it is. So think about it. The amount of training you're doing on your models is definitely going to improve if you have a little bit control on your data quality. The second thing is, now if you use a control mechanism, you profile that data, you do observability, you separate the bad data and good data, you control the noise level and train, there was a very big difference in the results that happened from the model training. So that is one use case, that once you have observability in the data, you get automatic data quality, you get incident management, but you also get better, more predictable model results, even for large language models. So this was the results, and you can download. This is a QR code. There's a full research output on our website, so you can take a look at this blog. It has code sample, so you can try it out yourself. You can leverage both the sample code and the research results there. And here you can clearly see that the results of the model, when you put clean data, as well as the results of the models when you put a little bit of truncations or anomalies in the data, mixed up titles, imbalanced, and so on. There's a very big difference, and this may look small on the bar graph, but when you're actually there's that ching-ching moment when you're training the model, it's so much of cost that goes into training. You can totally control this model training approach through this approach. The next thing is the other use case that I like to talk about from an observability perspective is, how do we improve our ability to give better and faster data products to the market? So I'll give you an example of a use case from TELMAI's customer, which is Clearbit. So Clearbit had a data stack where they had BigQuery, Athena, Redshift in a single data pipeline. They hired a data product manager to bring out data products into the market, and they had a full roadmap of how fast they should be bringing on this data product. Unfortunately, the reality is very different from what we try to do. In reality, the data product manager realized that most of her roadmap would be actually spent in looking at problems in the data, which is like finding out if the data on which you are building your models or even your analytical report had a lot of reliability issues. Now, Clearbit is a B2B data vendor. They take a lot of pride in the data quality. They even publish the data quality metrics on that. And the data that was flowing through the pipeline had web crawled from applications, web crawl data, application data. So it had a whole bunch of issues like missing data, unexpected values, out of range values, drift in the data. So what this team did is they implemented data observability. They had semi-structured data, which was in BigQuery with millions of records. And they had 2 options, either homegrown built like a query-based approach to figure out what is the data is consistently, predictably reliable, or they could go to an observability solution and start constantly monitoring data. So they implemented observability. What they got is out of the box a system that plugged into all 3 systems to extract insights into the data, including anomalies inside the data, drifts within the data, data quality KPIs like completeness, correctness, accuracy, a health dashboard that at any point in time across all 3 systems can tell where is the health of your data, how much of the data of this is accurate, reliable, has completeness, and so on. With all of this, what really happened is the data teams, including the data engineers and the data product managers, are now able to focus on actually building data products. And they also have a very clear understanding that the data products are built on a data where they have a very good understanding of the reliability of the data. So this kind of accelerated their ability to deliver faster data product into the system and accelerate their overall ROI of their data initiative. So those were the two use cases that I wanted to cover today. We have 15 minutes. I went super fast. I'm happy to actually dig into any topics that you may want to cover. So this was super fast, but I would open it up to question and we'll make it fully interactive. Any questions that you may have about data observability, how things work, I'll be happy to share more. Anybody has any questions?
Can you hear me?
Yes, I can.
Sorry, I was just wondering, what's your definition of data observability? What areas and components are involved in the data observability as implemented by TELMAI?
Oh, thank you. So the question here is, what is my definition of data observability? What components are used to be monitored for data observability? So as I mentioned, data observability is like, let me explain a little bit, take a step by. As a data observability company, the way we work is that we look at your data itself, the metrics of the data, we are observing the data, many different dimensions of the data. So let's take simple things like schema. The schema between two systems, has it changed? Has it drifted? Once you start observing these type of changes, you start monitoring it. The components that we use for data observability, I very strongly believe data observability should be implemented across your data pipeline from ingestion to consumption. Your source system are the typical systems that cause a lot of errors, issues, and that is where you have least confidence on the data. So the first step of data observability is to shift the monitoring to the left of your pipeline, to the source system where the data is getting ingested. Look for if there are any anomalies, outliers, or statistical drifts in how that data is ingested. Now, if you look at the data for source system, a lot of time the data is coming in raw formats. It's coming from third-party companies. It could be coming from web crawled, as I mentioned, in Clearbit use cases, right? And there's very limited predictability. This is semi-structured data or different formats. So once you get a handle on how is this data coming, at what cadence is it coming, what format is it coming, and you have a good sense on that, then you start monitoring that. Every time you see any type of an anomaly or a drift or a validation check broken, you will find out about it at the ingestion itself before it has downstream impact. The fun thing about data is it's transformational. The farther it travels from the source, the more complex it is for us to fix it, right? There are teams that change across the pipeline. The source system owners are completely different. The BI tool owners are completely different. Then there's a lot of finger pointing. The moment you find the issues where they happen, then you've already solved most biggest problem, which is the organizational conflict, right? So first thing, observability should monitor every component of your data pipeline. And observability as a definition is a way of applying statistics and machine learning principles to observe your data, metadata, and aggregate it to find anomalies and outliers on the data. Hope that clarifies. Thank you. Any other question? This is a fun thing. You can ask me anything. I've spent at least 3 years of my life talking to people about this problem. So I'm no filter. I'll give you all honest answers. I can't hear you.
Hello?
Yes.
Oh, yeah. So just wondering, there are so many companies and vendors out there doing data governance, data qualities, kind of like a solution. What kind of like makes TELMAI unique and more competitive to others competitor? Thank you.
Yeah. So I'll repeat the question if everybody's not heard it. There are a lot of tools and vendors that are doing data governance, data quality, and even data observability. I'll add to that what is the big difference in TELMAI. I'll definitely tell you the big difference in TELMAI, but I'm a product manager. So I'll tell you the first thing. The first thing is you need to look inward, what your use cases are, and own those use cases before you start looking at the tools, right? So first step is like, yes, there are a lot of tools, and there will be a lot more tools coming in the space, but look at what use cases you have, what ecosystem you have, what are your top challenges first. Now, when it comes to TELMAI, we have three big differences when it comes to data observability space. The first thing is we go super broad. From ingestion to consumption, we call ourselves as the data observability tool designed for open architecture, which means that we can support your SQL data source, non-SQL columnar data sources, your data lake ecosystem, Delta Lake ecosystem, but we can also support your legacy system, on-prem system, because that's the truth of the world. Like, not everybody is on your data warehouse. Some people are using event streamings. We can even connect to your Kafka queues and streaming sources, so any source, right? You are looking at your data across all these systems. So that's our number one differentiation, and different type of data formats, Parquet, nested JSON, and all of those things. And all of this goes back into our architecture and how we look at observability. We don't run queries on your data warehouses. We have a decoupled engine which does metric calculations. So that's number one difference. We go broad. Number two is we go super deep. So we don't just look at the metrics like schema has changed, freshness has changed. The true value is what we know about data is it's easy to find the known unknown through validation rules. That, yeah, this is control pick list. I know what the values are. I'm going to throw a rule, and let's put a rule on that. Those problems are solved through rules. But there are other set of problems which are typically out of range values. The revenue of this company has been in the range of 5 to 10 million. Suddenly, fat finger syndrome, somebody put an extra zero. How did the revenue go to 100 million? These type of issues have a direct business impact because it's hard to find. No quality checks can easily find because the data has followed all the validation rules, but it's out of predicted range. And these type of rules can either be done by eyeballing, or you apply a good machine learning model to detect anomalies. So that's where we go at column value level, and we figure out, does this value look right in the range or what we have predicted? And the third thing which we really want to focus heavily for data observability specifically is that how do we make sure we make all of this achievable without adding latency on your data pipeline, making the async call possible and even synchronous calls possible to an observability tool like TELMAI. So low cost at good kind of no latency addition is the third dimension that TELMAI focuses on. Now that's about observability. Data governance, data catalog, there's so much. I don't envy you all because today the buyer has so many options and so many tools and so many categories. So there's data catalog and data governance tools. The legacy one are heavily focused on validations. Some of them have started now using observability and how they do it. But a lot of the focus of those tools has been validations based. Any other questions? No questions? Okay, so I believe if no questions, and I think we are 5 minutes, almost 5 minutes left. So we have a booth. If anybody is interested, there is booth number 730 where we can give a demo of TELMAI. You can take a look at TELMAI in action. You can take a look at observability, see how these products are designed, how they work, and start implementing observability. Thank you so much for your time, everybody.